Hey everybody, hope that you have enjoyed the last couple of days off with all the snow and the ice and all that good stuff. But we still have some things that we need to do, and the percent assessment still has to be on Saturday. So I hope that you take your study guide and watch this video a couple of times, and you should be in really good shape to take your major on Saturday. And of course, we'll be working on this Wednesday, Thursday, and Friday in the classroom as well. First, here are some key vocabulary words that you need to know and understand. I've given you all these words, but we're going to talk about these again because I really want to make sure that you are in good shape to understand and really get what these words actually mean. The first one here is percent increase, which is the amount something goes up from its original price. In money situations, this can also be called markup. Percent decrease, which is the amount something goes down from its original price. Again, in money situations, this is called either a sales price or a discount. 3, tax. This is an amount paid to the government. This falls into usually income or sales. Sales specifically is tax paid on what you spend. It is always in addition to. They don't ever give you sales tax back, typically. Tip, which is an amount paid to a restaurant server for waiting on you at the restaurant. This usually averages somewhere between 15 to 30% of the food cost. And finally, commission, which is an amount paid to someone based on sales. This usually goes to realtors, people who sell houses and land, and car salespeople. This is how percent can be shown. It can be shown using multiple ways. Percent questions can also be answered using multiple strategies. These include the box. This is what I've used mostly in class. It is a model that helps you see the relationship between percent and fractions. The 100 is like a denominator of 100. The word cent also means 100. Decimals. This is the way most of your peers and your family have been taught. Remember that decimals and fractions are representations of numbers. Most numbers can be written as either. And then we have fractions. As I keep saying over and over again, beginning next year and with nearly all of the higher maths you will take as you get older, it is super important that you have a firm understanding of fractions and how they work. I cannot emphasize this enough, knowing what you will take in Math 8, Math 1, Math 2, and Math 3, regardless of what you may decide to do as you get into higher grades. Here's an example of what I mean using the two strategies that I just listed. Here's an example of a box question. You take a major that contains 18 questions. You score 14 questions correctly. What is your percent correct? In using the box, you would first write 100 here. That is always what I call an anchor number. But regardless, that's just where it's set. That's where you set it up. And remember that our relationships are always vertical. You put an 18 in this box because if you had gotten 18 out of 18 right, you would have gotten 100%. The actual number that you got right, which in this example is 14, goes above the 18. And then you cross multiply and divide. 14 times 100, and then whatever that answer is divided by 18. In this instance, your percent grade would be 77.8 or 78%. In using decimals, you would have first divided the denominator into the numerator, which is 18 into 14, which I have shown there. And as you see, you get a repeating decimal of 0.77 repeating. Then you would multiply that by 100, and you would have gotten 77.7 repeating, which rounds up to 78. Again, to help you with strengthening your understanding of fractions, use the box. Over 1/4 of the EOG questions you'll answer this year all can be solved using this strategy. Decimals alone will not offer you the same value. What I mean by that is you're not going to use decimals for 1/4 of the EOG, but you can use the box for the EOG because the box helps you with percent, ratios, and proportions. Once in a while, it can even help you with algebra, but these are the main ones that it can help you with. Decimals it helps you with fewer things. All right, for the rest of this video, what I've done is I've created 10 questions, and what I want you to do is hit the pause button at the end of each question before the answer shows up. See if you can answer this question on your own. You need a calculator, graph paper, and a pencil, and then test your answers. If you get it right, that's phenomenal. If not, pay close attention to how you made your mistake, because even if you made a mistake, your assessment, your major, your EOG, all of those, the questions are going to be asked either at the same difficulty of what I'm saying in this video, or what I've said here is going to be a little bit more challenging than what you will be actually tested on. Remember that in class, I try to make things a little harder than what you will be tested on so that your assessments are that much easier. Percent questions and how to solve them in this example are going to be how to calculate tax and tip, markup, increase and decrease without using money, sale prices, sales tax, commission, and multi-step questions using several of the above situations. Okay, question number 1. A family goes out to eat at a restaurant. The bill is $41.98 before tax and tip. Servers are paid their tip with the sales tax added. If the sales tax is 8% and the server's tip is 25%, how much is the tip alone and the entire bill? Please pause. Take a few moments and try and set this up. All right, here is how you would set up this question. First, we have the box that includes our sales tax. And once we have set that up, we then do it over here for the tip. So let's look at how this is set up. The bill is $41.98 before tax and tip. That goes here because that's our original 100% amount. Sales tax, again. The reason why I write 108 in this box is because the kin tax is always added. I then cross multiply 41.98 times 108, divide that by 100, and I get $45.34. This number is then written over here, where I'm going to now calculate my tip. My tip is 25%, but because this question is asking for the entire bill and the tip alone, I'm going to write 125 to calculate first my total bill. 45.34 times 125 divided by 100 is $56.68. That's my total bill. And to calculate my tip, I then subtract the two numbers, and my tip becomes $11.34. Number 2, a department store sells all sorts of shoes. One shoe in particular that is very popular is one that sells typically for $129.99. The store itself buys these shoes for $50 a pair. What is the percent markup on these shoes? Pause, try and solve it, hit the button, and then you'll check your answer. Okay, let's look at this question in our box. The store price, or what the store paid for the shoes, is $50. That goes here. And the price that the store is selling them for is $129.99. Because this is money, it goes in this column. And I multiply $129.99 times 100 divided by 50, and I get about $260. That's not my answer. I need to subtract 100 because otherwise, if I were to say the answer is $260, I'm saying that the department store got those shoes for free. They spent money on them. They just didn't spend nearly as much. So our approximate increase is 160% after subtracting those two numbers. Number 3, a temperature at 6 a.m. begins at 26 degrees. By 3 p.m. it has increased to 44 degrees. What was the percent increase in temperature during the day? Okay, pause, set it up, and then check your answer. Okay, here's our box. My original temperature was 26. That goes besides 100. It had increased to 44, which is vertical above 26. 44 times 100 divided by 26 is 169. Again, that's not my answer because I have to subtract where I started from. 169 minus 100, I have about a 69% increase. Number 4. A line of cars aren't selling very well, so the company decides to mark them down to clear out its inventory. The original price is $29,500 for each car, but the company advertises that it is reducing the cost by $6,000. What is the percent decrease in the car? All right, let's look how we set this up. I put $29,500 beside 100, but I did not write $6,000 here. The reason is because if I had written $6,000 here, that would be like saying that's how much the car was selling for, which is an exceptional bargain. But that's not what the question is saying. Instead, it's saying that it reduced the cost by that much. Reduce means to subtract. So I subtracted $29,500 minus $6,000 and got $23,500. That is why I wrote $23,500 above the $29,500. Now I can cross multiply and divide. 23,500 times 100 divided by 29,500 gets me 79.6%. That's not my final answer. That's how much you're paying compared to what you were before. To find my discount, I subtract these two numbers, 100 minus 79.6. The discount was about 20.4%. Number 5. A person wants to buy new clothes for his significant other for a holiday. The store advertises that everything in the store is 25% off except for pants, which are 35% off. The person buys 2 shirts and a pair of pants. The shirts are $19.99 each normally, and the pants are $29.99 originally. What is the total price of the clothes after the discount is added and sales tax of 7% is added to the final bill? This is a multi-step question that requires at least 3 boxes. One for the pants, one for the shirt, and one for the final where you're adding the tax. Take your time, pause, set it up, and then check your answer. Okay, let's look at how I set this up. First, I calculated my shirts, which were here. My pants were in my middle column, and then my final box was my total. I write $39.98 here because I bought 2 shirts. And $19.99 times 2 is $39.98. It was 25% off, which means I'm paying 75% of the original price. $39.98 times 75 divided by 100 is $29.99. That is how much the 2 shirts are on sale before any tax is added. Now I'll move on to the pants. The pants were originally $29.99, and they are 35% off. If they are 35% off, you are paying 65% of the original price. That is why I wrote 65 there. $29.99 times 65 divided by 100 is $19.49. That's how much the single pair of pants are. In order to figure out this number, in order to calculate my sales tax, I have to add how much my shirts and my pants were all together. These two numbers added together equal $49.48. Sales tax is always added and is 7%. I'm writing it as 107 so that I can skip the step of if I had written it as 7 and then add those two numbers together. 49.48 times 107 divided by 100 gets me a final answer of $52.94. Number 6. A person sells a $456,000 home and earns a 3 5/10% commission. How much did this person get paid? This is a pretty straightforward one-step box. Pause and then check your answer in a few minutes. Okay. 456,000 is written beside 100 because that is how much the house was sold for. That's the whole thing. This person earns a 3.5% commission. 456,000 times 3.5 divided by 100 is $15,960. This is this person's paycheck or commission on the sale of the home. Number 7. A coffee shop buys coffee in 5-pound bags. Each bag can produce 120 cups of coffee. The bag is $25. If the coffee shop sells one size of coffee at $2.29 each, how much profit is earned on one 5-pound bag of coffee as a percent? This is handwritten in because my computer crashed when I was typing that up, so I just handwrote that in. So it's asking for this profit as a percent. Set up your box and check your answer in a few minutes. All right. I set up my box by putting 25 beside 100 because that's how much the store paid for it. To get this number, I need to calculate the sales price of each cup of coffee times how many cups a bag of coffee can produce, which in this instance is 120. 120 times 229 equals $274.80. That's written above 25. Then I cross multiply and divide. $274.80 times 100 divided by 25 gets me $1,099. Now remember, that's not my final answer because I need to subtract 100 from the end because the coffee shop did pay $25 for the coffee. It was not for free. $1,099 minus 100, my final answer is a 999% profit increase. This is how much the coffee houses typically make. It may not be this extreme, but they mark up their coffee substantially. Number 8, a car sells at a dealership for $28,500 and takes a 20% depreciation after 1 year. What is the value of the car after 1 year? There is a word here you may not know, depreciation. That means to reduce in value. Appreciation means to increase. Pause, set up your box, and then come back and check your answer. Okay, so 20% depreciation, 100 minus 20 is 80%. That's why I wrote 80 here, because that's how much the car is worth as a percent of its original price. 28,500 times 80 divided by 100 gives me a final answer of $22,800. That's how much the car would be worth after 1 year. Number 9. Credit unions usually pay better interest on money than traditional banks. Two people, each with $20,000 in their savings accounts, are comparing how much interest they make in 1 year. The credit union pays 1.5% interest each year. The bank pays 1.25% of interest each year. How much more interest does the credit union person earn after 2 years? This is a 2-boxer, one for the credit union, one for the bank. Set this up, try figuring it out, and then come back and check your answer. Okay, so this is my credit union box here, and this is my bank box here. I have 20,000 and 100 in each box in the same locations because that's how much money is in the bank. My interest rates are here and here. 20,000 times 1.5 divided by 100 is $300. 20,000 times 1 1/4 divided by 100 is $250. So the difference is $50 a year. But remember that the question was over 2 years at the end, and 50 times 2 is $100 more in interest after 2 years for the person who has an account at the credit union. Last question. A person requests a pay raise of 25% but gets 15%. The person's old salary was $3,900 a month. How much more money does this person earn in a year after or with the raise? Okay, so this person earned a 15% raise, which is 115 because I'm adding the raise to it. Raise means increase. And then 3,900 goes here because that's how much the person was originally earning per month. 3,900 times 115 divided by 100 produces a new salary of $4,485 per month. I then compare that to the old salary of $3,900 by subtracting the two, and this person is earning $585 extra a month than before. But because the question's asking for it in a year, I then multiply this number times 12, and this person is now earning $7,020 extra a year with the raise. Ask any questions in class.